everybody. Welcome back to the developer track at CloudStack Collaboration Conference. Next up, we've got David. David's going to be talking about what's new in CloudStack Kubernetes Service. Over to you, David.
All right, thank you, Giles. Hi, everyone. Welcome to my session on what's new with CKS. So let's start a bit about me. So here's a picture of me back when the world used to make sense. So a little bit of trivia about me. So I am the first of my name. So I like to think that because if you go and try to search for David Naresh Jumani, you'll only find one result. So I'm the first of my name, unless I decide to get narcissistic and name a son after myself. I am the firstborn. So most people brag that they're a dad of two or things like that, but I'm not in that stage of my life yet. So what I do have is a younger sister. Those of you who have younger sisters, you know what a pain they can be. Those of you who are the younger sister, now you know what your brother really thinks of you. That being said, I still love her. Then apart from that, for my hobbies, I enjoy playing sports. I especially enjoy playing rugby. Then coming.
David, your microphone's gone off. David.
Hello.
That's it. You're back.
Okay. Yeah, so I'm a CloudStack committer. I've mentored a couple of GSOC projects as well. And for work, I'm an engineer at Shape Blue. All right, so that's enough about me. Let's get to it. All right, so just to start things off with a bit of humor, this is the origin of containerization and how I really believe Docker was born. All right, now that I've got a smile on all your faces, let's get to it. So this is a quick rundown of my presentation. We'll start with a quick recap on what is CKS, followed by the new features that are in it in 4.16, a demo, and then time for a quick Q&A. All right, so the first thing is, what is CKS? So CKS is CloudStack's Kubernetes Service. So what manage Kubernetes offerings? So that means it's KAS, Kubernetes as a service. So it is a seamless integration with CloudStack, where with just a few clicks of a button, you can get a Kubernetes cluster up and running.
David, sorry, lost you again. David? No, still haven't got you.
Hello?
That's better.
Okay, perfect. All right, so it's seamless. It's a seamless integration with CloudStack. So with a couple of clicks, you can get a Kubernetes cluster up and running. So it's not just up and running, you can manage the entire life cycle. You can create it, you can scale it up, down, you can upgrade Kubernetes versions, and finally, once you're done with it, you can delete your Kubernetes cluster. So this is just a quick view of the UI, how you can create a cluster. I'll show you a bit of this in the demo. You go to the UI, head over to Kubernetes, create a cluster, enter all the details you need in the form, and finally you have a cluster up and running. So what you have here is this fantastic architecture of Kubernetes. Now that we support it, we can slap our name on it and say Kubernetes is now powered by CloudStack. All right, now getting to what is new in Kubernetes. So we got 4 main things which are new in Kubernetes in 4.16. So the first one is it is architecture agnostic. So previously it would work only on AMD 64 machines. That has been fixed, so now it can run on both AMD as well as ARM 64 machines. The second major one is the CoreOS replacement. So CoreOS went end of life, and now we have a new default OS for Kubernetes. Third is the CloudStack Kubernetes provider. This is not specific to CKS, but there are a lot of use cases wherein it integrates with CKS. And finally, we have support for autoscaling. So as you can see, just as technologies have evolved, CloudStack has evolved with it. All right, so let's get into the first one, which is the CoreOS replacement. So when CKS began, the default OS for CKS was CoreOS. It was a containerization OS made specially for that. But unfortunately, it went end of life last year. And yeah, we couldn't do anything about it. So what we had to do, we had to move on. Anyway, the process up till 4.16 was that once was that when you need to get a Kubernetes cluster up and running, you need to first register your CoreOS template. That means you have to download it, register it on CloudStack. And after that, you would have to go to the global settings and then set the value for that template name as the default Kubernetes cluster template. So that was a long-winded procedure. And since CloudStack is a turnkey solution, we decided, hey, why do we want to go that route? Let's just fix it. So we came up with a pretty good solution, which is let's use Debian. All right, so now, great, we've selected Debian. Now, okay, we have a system VM template that is also Debian. So why don't we just go ahead and use that? And so we tweaked our system VM template. So now that is also the default template used for Kubernetes. So the brilliant part about it is now there's no prerequisite. You don't have to upload your template. You don't have to register it. There are no special global settings. And the best part is you don't even have to register your system VM template with 416. And there was some brilliant work done by one of the other committers, Pearl, and just piggybacked on it and got autoscaling implemented in that PR as well. All right, so now let's head on to the second new feature, which is the CloudStack Kubernetes provider. So what does it do? So in Kubernetes, you have load balancers. So load balancers can allow traffic and creates pretty much an IP which you can hit, which balances traffic across your Kubernetes services. So that's the way to expose your service to the outside world. So what does this do? It acts as a cloud control manager, which is just a fancy way of saying it's a cloud provider. And it handles load balancers. So it bridges the gap. It allows Kubernetes to communicate with CloudStack. And a bit of trivia is that this was historically a part of Kubernetes, but it was taken out to separate out providers so that Kubernetes wouldn't need to be bundled with all the cloud providers as part of it. So how does it work? So every load balancer is essentially an IP which is exposed to the outside world. So mapping that onto CloudStack, an IP that's exposed to the outside world, that's a public IP. So for every load balancer, it dynamically allocates public IPs. Great. Now that you've allocated an IP, a load balancer also balances ports, right? So you have to have your port forwarding rules. So it forwards the public port, which could be a HTTP, HTTPS, whatever, and it forwards it to the respective node port. So which is the port it's exposed on the Kubernetes node. So not just port forwarding, it needs to also open the firewall rules so the traffic can get through. So it does that, and it supports TCP, UDP, as well as TCP proxy protocols. All right, so let's see how this works behind the scenes. So we have Kubernetes, which is running, and it runs as a cloud control manager pod, because on Kubernetes, everything runs as a pod. So what does it do? It ensures load balancers. So whenever a load balancer is added, it adds a public IP, it adds all the required networking rules. When it is removed, it removes those, it deletes the IP as well as removes the networking rules on CloudStack. And not just load balancer rules, but also when your cluster scales up, it needs to add the new nodes to the load balancing rule, or when it scales down, it needs to remove that node from the load balancer rule. So it does quite a lot. And it also communicates with CloudStack. So as you can see in the diagram, Kubernetes talks to the cloud control manager whenever there's a change in infrastructure or when a load balancer rule has been modified. And the cloud control manager in turn talks to CloudStack to get everything set up on the infrastructure side. And now the Kubernetes provider is also automatically deployed as a part of CKS. So previously you had to deploy it separately. You had to create certain secrets, deploy those secrets, then deploy the provider, but now it just comes out of the box. So here's an example of the mapping. So you would create a YAML which has a load balance over here, and expose a couple of ports. So the load balancer is mapped to a public IP on CloudStack. You got HTTP port 80 mapped to port 80 in the load balancer rule, and the private port is the port on the node on which it's mapped. Same thing for HTTPS, because you'll have to shoot yourself in the foot for managing certificates. It load balances the HTTPS port on the same private port on the node. So you guys are like, okay, yeah, this is great. This is for advanced users. But what about for someone who's just trying out CKS for the first time, seeing how viable it is for our production, or I just want to have fun. I want to learn Kubernetes. So one great example would be exposing the dashboard via a load balancer rule. So generally, whenever people have to bring up a cluster, what they do is they bring up a local Kubernetes proxy on their system and then access the dashboard. But now with this, you can just create a load balancer rule, which will allow you to directly access the dashboard without any configuration on your end. And I'll go and I'll show you guys this in the demo. All right, now that that's done, let's get into the CloudStack Autoscaler. So what does it do? So I'm sure you heard Giles talk about it on what's new in 4.16, as well as Rohit mentioned it. So it does pretty much that. It automatically scales up your Kubernetes cluster. So it needs no intervention from the user side. It doesn't need any user interaction. With just a couple of clicks, or here just one click, you can enable autoscaling on your cluster. And this is a major milestone in CKS, since this is a major integration with Kubernetes from CKS. So what are the benefits? Well, that depends on your CTO, but since I'm not the CTO, I'm just a regular engineer, here is my insight. So the first thing is that it is the Kubernetes recommended way of automatically scaling your cluster. So when you read the Kubernetes documentation, it discourages you from using external monitoring tools and deciding whether a cluster needs to be scaled up or scaled down. Kubernetes has its own algorithm which does that, and that takes into account a lot of factors, not just utilization, but taints and other things like that. And the other advantage being an engineer is that you get to peacefully sleep. You won't be woken up in the middle of the night knowing that when you're on call, seeing that your cluster is out of capacity, and you can sleep peacefully knowing that you're not paying for additional capacity which you're not using. All right, so how does it work? So we have the Kubernetes scheduler, which runs on your cluster. And now you have your autoscaler pod, because again, Kubernetes, everything is a pod. So it runs every n seconds, so it runs in a main loop. So what does it do? It checks whether any pods are unschedulable, whether that's because of certain taints or because there's not enough capacity on your cluster. It checks that. And when it realizes, hey, yeah, these pods are unschedulable, let me figure out what can be done. And then it'll do its fancy little algorithm, and then it'll say, hey, yeah, I need to scale up my cluster. Now that it's scaled up, great. So now you have way too many nodes in your cluster. So what does it do? It sees, is a node unneeded? Has it been idle for long enough? Okay, fine, great, it's idle. Now, does it have a taint that says, ignore me from scaling down? So it takes a lot of factors into consideration when it scales down. And not just that, since you don't want your scaling to look like a sine wave, what it also has is it has a wait time or a cooldown time. So right after it adds a node, it has a wait time. So it doesn't keep adding nodes, or it doesn't add a node and then remove it because that was a spike in activity. It also right after removing a node, it doesn't go back and add it. There's a cooldown period. All right, so let's go into behind the scenes. How does this work? It works as an autoscaler pod. So it works the same way as the Kubernetes provider. It communicates with CloudStack. So the scheduler tells the autoscaler, hey, yeah, guys, we need to scale up, we need to scale down. And the autoscaler in turn translates that to APIs, which CloudStack can understand. So now you guys are pretty much asking, hey, yeah, this is great, but how does it communicate with CloudStack, right? It's running in a cluster. It needs to communicate, it needs to know the URL, it needs to know the API keys or some way to authenticate itself. So yes, for that, CloudStack automatically generates API keys for it. So in the same account as the cluster owner, it creates a new user called kubeadmin. So this new user kubeadmin gets the API keys which are used, and it also uses the endpoint URL global settings. So CloudStack will throw an error if it's not set before you create a cluster, to make sure that the autoscaler and the provider work out of the box. All right, that's it. Let me get into a demo to show you a couple of the new features in CloudStack. All right, so I have my Kubernetes cluster ready over here. As you can see, I have it. It has two instances, a control node and a regular node. And I remember someone asking whether it supports a custom registry. So you go to Kubernetes, create a cluster, and there's a global setting called Kubernetes experimental feature. So once that is enabled, you can go ahead and add your private registry. details while creating the cluster. All right, let's head on over to our cluster. And we see that it has 2 nodes and it has one public IP, which is the endpoint for Kubernetes. So the first thing I'll be demoing is the CloudStack Kubernetes provider, followed by the autoscaler. So let's head on over here. So over here, I've done a few things prior to this. I've created the dashboard as well as a login token for it, and I've applied the metric server so that you can see everything up and running. So now if you look at the public IP, there's only one IP for the CKS network, which is just the endpoint. So what we need is we need another IP, and I've created it via load balancer rule so that it exposes the dashboard service. So that should come up on 10.0.58.3, and right now if you hit it, you can see that it's unable to connect. So let's go ahead and apply it. So just to give you guys a look into what that is, it just creates an Nginx deployment, the config map, all the required permissions, as well as a load balancer that balances port 80 and port 443 to the dashboard. So let's have a look right now that it's been applied. And there you go, a new public IP has been created. So now if we were to hit that IP, all right, so we just need to give it a little time to make sure that the Nginx pod has come up. So let's have a look. You can see here that we have our Nginx pod, and here you can also see the Kubernetes provider running as a cloud control manager. All right, so now that the pod is up, let's refresh our page. Yes, we're able to access it. And now we can happily access the dashboard. So you can have a look at the Kubernetes, the way our cluster is operating, all without running a kube local proxy. All right, so that's my example for the Kubernetes provider. Let me go ahead into the autoscaler. All right, so you guys have seen that my cluster right now has only 2 nodes, a control node and a worker node, right? So what I'm going to do is I'm going to use a production example. So right now I have a PHP pod. Which is up and running. So it's just a simple deployment of a single PHP pod and exposing it via a PHP service. So now with that, I'm going to enable HPA, which pretty much scales your pod based on the load. So what I have done is I've created is that I've auto-scaled the deployment. So now if the CPU crosses 5%, I want you to scale up the number of pods and go from a minimum of 1 pod all the way up to a maximum of 40 pods. So I put 40 over here because 2 nodes won't be able to handle 40 pods. So based on that, the autoscaler should kick in when it realizes there are unschedulable pods and scale up the cluster. So for that, I'm going to first log the autoscaler so you guys can have a look at the logs and see what's going on. And now I'm going to load the cluster. So if this thing seems complicated for you guys, this is just the default way that Kubernetes shows an example of autoscaling a pod as well as a cluster. So now we can see the logs from our autoscaler. We can see they're starting in the main loop, and right now nothing needs to be done. So let's go ahead and load it up. So all this thing is doing is continually hitting that service, so it increases the load on the service, which will cause it to scale up the deployment. So let's put a little watch on it so we can see what's the CPU utilization and watch it scale up. So right now it's just started. So there's 0% utilization. Well, let's just give it some time and you should see it scale up the number of pods, which will eventually scale up the number of nodes in our cluster. All right, so while that is happening, are there any questions, Giles?
Put me out there, David. Yes, there are. There's lots of questions coming in. Let me.
Okay. Yeah, I can take on a couple of them before I get back into the example.
Abhishek has asked, is it possible to configure the cooldown time interval dynamically? Is it used for both upscaling and downscaling?
Yes, so right now the autoscaler pod just works with the default, but you can go ahead and edit the deployment in Kubernetes itself. You can do kubectl edit deployment, and over there you can customize the cooldown time.
Cool.
All right, yeah. So just a minute, Jed, let me just head on over to the example. So here you can see that it is scaling up the number of pods in our cluster. So now it should start scaling up our cluster. So if we look at the logs, we can see that there are a bunch of unschedulable pods, and we can see that the autoscalers realize, yeah, right now we need one node. So what's our scale up plan? Let's scale up our cluster from one node to two nodes. So from one worker node to two worker nodes. It doesn't consider control nodes. So what's happening? It's increasing the cluster size by 1, and it hits the API URL, which is our CloudStack URL, and it says scale Kubernetes cluster. So now if we have a look at our cluster, you can see that it's scaling up. And look at the number of instances. There are 3 instances now, 1 control node and 2 worker nodes. So just give it a minute for it to completely scale up. And this is a real-time production example of how the autoscaler works based on the workload on the cluster. All right, so while that's going on, let me kill the load. Let me kill the load. So then the number of pods will come down and it can eventually scale down. All right, so that is my demo. All right, Giles, back to you for the Q&A.
Okay, we've got a lot to get through, David. Let's get going. Alex has asked, how large can that scale?
Okay, so that can pretty much scale depending on your cluster, on your CloudStack instance capacity. You can even have it scale from 1 node all the way to 20 nodes. It's just up to what your infrastructure can provide.
Get it? Yeah, and what their quota is and what their limits are.
Yes,
In
exactly.
their account, that sort of thing. I get it. What else? Sorry, Andrea asked this question. What else is the CloudStack provider capable of doing?
So right now, the CloudStack provider is only capable of handling load balancer rules. So if you have a service running in Kubernetes, you would want to expose it to the outside world. So the only way to do that now is via a load balancer rule. So you can create a load balancer rule, and now your service, which is running in Kubernetes, is exposed to the outside world on CloudStack via a public IP.
But in the could there be other things in the future that it could do?
Okay, so the way Kubernetes works is it has different managers for different tasks. So if there is something new, it would end up being a separate manager under a separate provider.
Okay, get it. Okay, that makes sense. Abhishek has asked, how do you enable the auto-scaling whilst creating the CKS cluster?
Oh yeah, I just forgot that. So let me show you. Okay, so now we see that a cluster is up and running, and if you have a look at number of nodes, there are 3 nodes. So now let's go to our cluster. So we have a cluster, we want to scale it. So let me go to scale Kubernetes cluster. So if auto scaling is not enabled, you'll see this. So you just tick this, enter the minimum size of the cluster, the maximum size, hit OK, and it kicks auto scaling on our cluster. It brings up the autoscaler pod.
And you would do that when you create the cluster in the first place, right?
Well, it depends on whether you want to enable autoscaling. If you do, you do this once the cluster is created.
Those limits that are in there, that were in there before auto-scaling, I assume it still respects, in fact, I know it still respects them.
Yeah,
because I'm thinking aloud.
Yes, because let's say your workload is way too much, but you've only instructed it to go to a maximum of 3 nodes, so it will not cross that margin. Same thing, if your minimum, even if you have like 10 idle nodes, it won't go below that minimum value.
Get it. Okay. Next question. So Wei has asked, what metrics does auto scaling rely on, and can we change those values? I think you mentioned that it's the algorithm from Kubernetes.
Yes.
But can we configure that?
Yes, to some extent you can configure it. One is the wait time, of course. The other is you can taint particular nodes. Then you could also break up your cluster into separate node groups, and then you could scale up a specific bunch of node groups rather than the entire cluster, because there might be applications which need a GPU. So those will work only on nodes with that taint, and you can create a node group and it can scale up only that node group.
It's a bit like a tag, I suppose, in CloudStack.
Yeah, yes, pretty much.
So we don't worry about CPU. We don't worry about memory. We let Kubernetes figure all that stuff out, right?
Yes, exactly. Yes, that's pretty much up to Kubernetes.
Okay, so next question. Harry has asked, are there any plans for having operating system agnostic images for CKS, not to just restrict it only to CoreOS and Debian?
Well, that depends on the future plan of CKS as well as the demand, because if we need to have something OS agnostic, it would need to be one way would just have Kubernetes and Kubernetes, which would be a bad idea. But just to answer your question, I'm really not sure about it. It depends on what the community decides.
Get it. So to be figured out yet.
Yes.
Nicholas, are the CloudStack provider and the autoscaler separate components?
Yes, they are separate components and they run as separate pods in our cluster. So here you have the autoscaler, which is a completely different entity. It handles only one job, which is scaling up or down the cluster. The other one is the Cloud Control Manager, which is the provider. It runs as a separate pod in a separate service, separate deployment, which only handles ensuring load balancer rules. So just like in Kubernetes, everything is segregated, everything is a separate service.
Okay, and David, this is just from me. Where do people get that controller and get that autoscaler? Do we bundle it with CloudStack, or do they have to find that independently?
Yeah, so it is bundled with the CKS binary ISOs when you upload them on CloudStack. So this can work in an environment that doesn't have any access to the internet. Get
it. Okay, next question. Vladdy has asked, how easy is it to troubleshoot problems with the provider? And I'll add on to that, and the autoscaler as well. Now we know they're separate.
All right. So as I showed in my example, the logs are pretty verbose. So you can have a look and see, okay, so now it called this API, and if it failed, you would see the reason for failure over here, the API response, and then you can dig into the logs on CloudStack and see what happened. Because the autoscaler and the provider, they are pretty much a middleman for Kubernetes to communicate with CloudStack.
Yeah. Okay. Get it. So next question, Justin has asked, what about persistent storage? Is the CloudStack driver deployed by default? If not, is there a way to do that? I think that's two questions, I think, is it?
Yeah, so CSI...
is the CloudStack CSI driver deployed by default?
Yeah, so the CSI driver is not deployed by default, so you'll have to go and manually deploy it if there's a need for persistent storage.
Okay, I get it. I think Lucian's asked one about customizing the algorithm for auto scaling. I think we sort of touched on that earlier.
Yeah, so there are a lot of fields. So if you go to the FAQ in Kubernetes, here you'll see a list of all the possible configurations that you can tweak. So here there are a whole lot of configurations that you can tweak to customize it based on your environment and your requirement.
Okay, so I'm just trying to unravel Edward's question. CKP, how it runs so far in beta testing, in the same sense of percentage bugs found. It seems to be another layer of software introduced. So if I paraphrase your question, Edward, I think you seem to be saying, oh, another layer to go wrong, right? What's your thoughts on that, David?
Well, this runs as a separate entity. So if you're not deploying load balancers, you don't even have to worry about this.
Yeah. And that maybe I suppose that you could ask that question of CKS generally, right? I mean, in terms of it is another layer.
Yeah. But what we aim to do is, as CloudStack's turnkey solution, we also want to provide Kubernetes as a service to make it a holistic offering.
Yeah. Get it. Another one's just come in from Pierre-Luc. Okay, so CloudStack's responsible to create the Kubernetes cluster. How do we handle upgrades of Kubernetes?
Yeah, so if you would like to upgrade, you can go here. You can upgrade your cluster. You can choose the new. So right now it's 1.2.1. You can upgrade to 1.2.2, hit OK, and it'll upgrade all the nodes of your cluster.
Okay. And how are those versions? How do the versions get in that list, David?
So what happens is when Kubernetes releases a version, what we need to do is you need to bundle it inside an ISO. So there is a script which is part of the CloudStack repository, which you can run, which bundles all the relevant dependencies into a single ISO, which you can upload. So you can go to images, Kubernetes ISOs, and you can upload your new version.
Get it. Makes sense. Abhishek asks, what do you think is the next big improvement in CKS? Or what would you like to see in CKS, I suppose, would be the answer. So you don't hide behind, depends what the community want you to see.
Well, to me, it would be getting a tight integration with Kubernetes and deploying all the other drivers as part of it. So there's no need like the CSI. We can deploy it as part of Kubernetes. So as soon as you want something up and running, you can pretty much deploy it. You can create a deployment and go ahead with it rather than having a list of dependencies to make sure it exists on your cluster.
Brilliant. There are a couple of other questions, David. If you could just do those on text. I've just realised we've gone over time. If you could just do those on text afterwards. Final thing for me to say, everybody, please give David a big virtual round of applause. Certainly the funniest talk of the conference so far. Well done,
Thanks,
David.
Giles. So here, guys, is my contact details. You can get back to me and a bit of parting humor.